Alright class, sorry I couldn't be there today, but I've recorded this brief lecture on the topic of sampling and generalizability. Now, a lot of the claims we see made about social life, they're based on samples. Sociologists and criminologists and whoever, they take samples because we can't count every single person or measure every single person, and so we look at some subset of a larger population and use that to generalize to that population. You see this all the time in things like political polls about which candidate's going to win the next election, or in any sort of claims you see about the average American does this or that, or the crime victimization rate is X or Y. Usually these are based on a sample of a few hundred to a few thousand people, and we generalize based on that sample to the entire state or country or whatever the population is. So a couple basic terms here. One is population. Population is just the group of people, places, or things that we're generalizing to. And sometimes we use the word target population to specify that this is the target of our generalization, but people just say population and understand what they're talking about. A sample is a small subset of things from that larger population that's the basis of our generalization. Now, the problem with generalizations is that they can easily become overgeneralizations, and we saw at the very beginning of the course that that's one of the most basic errors in inquiry that there is. It's an error in reasoning called overgeneralization. There's a related error in observation called selective observation, and it's a problem that's connected to overgeneralization. When we generalize based on a selective observation, it practically guarantees an overgeneralization. So these two twin problems are a problem with sampling. One classic example of a bad sample leading to incorrect conclusions comes from the 1948 presidential election. Going into this election, polls by the Gallup polling organization showed that candidate Thomas Dewey had a firm lead on candidate Harry Truman, and such was the reputation of the Gallup organization that some newspapers actually printed the headlines in advance the day before the election, claiming that Dewey defeats Truman. Because of bad sampling, the polls were off, and their conclusions were off, and Truman actually won the election, which is why there is this famous historical photo of Harry Truman smiling and holding up the headline, "Dewey defeats Truman," on the day of his victory. Sampling methods are a set of techniques that are meant to safeguard against overgeneralization and selective observation. How do we safeguard against overgeneralization and selective observation? At the most basic level, what we're trying to do is make our sample representative. A representative sample is one that reflects the characteristics of the larger population. So if I'm looking at the population of the US and I want a sample that reflects the population of the US, I want to have the same percentage of males and females in my sample that there are in the US population as a whole. I want the same percentage of African Americans, the same percentage of urban dwellers and rural dwellers, and so on and so forth. You want whatever characteristics there are in the population reflected in the sample in about the same percentage or proportion. How then do we get unrepresentative samples? Why do bad samples happen? There's a couple of sources of error in sampling. One is sampling bias. Bias is a systematic error. You can actually think of this as being the same thing as selective observation. We have a sampling method that for whatever reason is pushing us towards observing a certain kind of person, place, or thing, but not another kind. It's systematically excluding certain observations. Say, for example, I have a survey method that, for whatever reason, is systematically more likely to sample women than to sample men. And I might have a population where 60% of the people are female, but in my sample it winds up being 80 or 90% female because I've systematically excluded males. Sampling bias refers to systematic errors of this kind, to problems of selective observation. Sampling error is a term that refers to random errors. These errors are not systematic. It's not that our method biases us towards observing a certain particular kind of case or not seeing some other kind of case. It's not that certain types of individuals are more likely than others to wind up in our survey. The problem is just that even if our sample is completely unbiased, it's probably not going to be perfectly representative. Random sampling error is inherent in the fact that we're doing sampling at all. The very fact that we're not counting every single person, that we're not doing a census, means that there's probably going to be some degree of sampling error. Now, if our sampling method is unbiased, this error will be random, it'll be scattered, it will not be pushed in any particular direction, but it's probably going to be there. In survey research, people use the term sampling error to refer to random errors of this kind. And sometimes when you see survey results, such as political polls, reported in the news, they'll use a statistic called margin of error. Margin of error is more or less sampling error. It's saying that, okay, even assuming everything else in the survey is correct, it's an unbiased sample and people answered the questions honestly, we still have to expect at least this much error. We're probably going to be off by 3% or 5% or whatever, just based on random luck of the draw. Sampling size is one of the main determinants of sampling error. There's two things that go into making sampling error. It's the size of our sample and the diversity of our population. The more diverse a population is on whatever characteristic, the greater your odds of missing some particular type of that characteristic. Like the more different categories you can divide people up into, the greater the odds that you'll miss one of those categories by random luck. But the bigger your sample size is, the lower the odds that you'll miss anybody. So the more people you look at, the greater the odds that your sample will be representative. We can actually quantify this relationship between sampling error and sample size. As the sample size increases, the degree of sampling error, the margin of error, predictably decreases. And this is so predictable that if you're designing a poll, you can decide in advance what margin of error you're willing to live with, and then you can work backwards and pick the sample size that you need. So how do survey researchers take samples? Well, the first step is you need a sampling frame. Frame just means a list of people or places or things that you can pick your sample from. Now, this is more complicated than it might sound. It's hard to find, say, a list of every person in the country. And so sometimes researchers have to get very creative deciding what they consider to be a list. We've already seen examples of survey research that uses the phone book as their list. They went through the phone book and picked out names. And in that case, the phone book would be the sampling frame. The frame doesn't always have to be a written list, though. It can be something like, say, all the houses on a street. Our method of taking a sample is to go to every other house and knock on the door, or every third house and knock on the door. In that case, the houses or the doors would be our sampling frame. And here we encounter the first big problem in drawing a sample. Our sample is only going to be as unbiased as our frame. Here again, it's hard to find lists of all the different people and places and things in the population, and so the lists we find are often incomplete. We talked about this a bit back when we looked at the delinquency of Chinese Canadian youth, and they went through the phone book and they found people with Chinese last names. Well, not everybody is in the phone book. And more importantly, the people who are in the phone book might be different than the people who aren't. When our frame is biased, when our frame differs from our population, when the list excludes certain kinds of people, it leads to an error called coverage error. And you can think of this as being the frame does not cover the entire population. So if our frame doesn't cover the entire population, it's coverage error and it's a source of bias. Famous example of this comes from the Literary Digest poll. So Franklin Delano Roosevelt was running for US president, and Literary Digest commissioned this huge political poll. Like, the sample size was enormous by modern standards. So huge sample, probably very little random error. But size is not everything, because their sample was biased as hell. And why was it biased? Well, Literary Digests got their sample from lists of telephone subscribers. And remember, this election would have been back in the 1930s when the Depression was on, and a lot of people didn't have telephones at all. And it also got its sample from a list of automobile owners. Here again, 1930s, cars less common, nation much poorer, depression going on. So this way of sampling people systematically excluded poorer people, more rural people, people who couldn't afford cars or phones. And guess who those people tended to vote for? They tended to vote for Roosevelt. So the Literary Digest poll incorrectly said that Roosevelt's opponent, a guy named Alf Landon, was going to win. He lost the election, and then they published this apology, and their polling error was a result of coverage error, which was a source of bias. So we have our frame, And now we have to pick cases from it. How do you actually take the sample? And there's two main families of methods. There's probability sampling, which is also called random sampling, and then there's non-probability sampling. So random sampling is the use of any sort of chance method, any random method. It could be a roll of the dice, it could be a computer random number generator, whatever. It could be names in a hat and you shake up the hat. The point is that there's chance involved, random chance. Random sampling has two main advantages. One, because it's random, it's left up to chance. There's no human influence over how the cases get selected, and so there's no possibility of systematic bias, or at least it reduces systematic bias. There might be some bias in the sampling frame or other aspects of the study, but there's no bias in how we're picking cases. It's all down to chance. A second reason that random sampling is preferred is that it allows us to use probability theory. See, randomness, the way we use the term in everyday life, we often think random means unpredictable, but random actually is predictable. A coin flip is a random thing, but it has predictable odds. It's 50-50 whether it's going to be heads or tails. And because random odds are actually predictable, you can use probability theory to estimate things like the degree of sampling error. So a lot of our inferential statistics, statistics we use to estimate how accurate our samples are and what degree of random error is involved in our samples, it depends on using probability sampling. So two main reasons to prefer that: it reduces bias and it allows us to use probability theory. Non-probability sampling, though, has its uses. There's a lot of different methods of non-probability sampling that social researchers just have to use because they're appropriate for the information we're trying to get, or they're just the only thing available. Convenient sampling is what it sounds like. That's just sampling what's convenient to find. You see this all the time when people, give surveys and interviews of their students. You also see things like snowball sampling, which is a method where you're trying to find a population it's very hard to reach. There's no list out there. Things like criminals who are active and haven't been caught yet. And so what you do is you find one person willing to talk to you and get them to introduce you to the next person willing to talk to you and kind of work your way through the social network. Here again, the way we pick cases from our frame can itself be a source of bias. I mentioned the example of the Dewey defeats Truman mistake. And in this case, that was the source of the error. Their frame wasn't terrible, and their sample size wasn't terrible, but the selection method they used was called quota sampling. Actually, the idea of quota sampling, it's a method of trying to make your sample more representative by making sure you have quotas of different categories of persons. So say in advance, the population's 60% female and 10% black and whatever. You make sure your sample is 60% female and 10% black. You set a quota. What happened in this particular case, though, was the quotas were wrong. They set the quotas based on out-of-date information. They were using the US Census to figure out how many people in the country were rural, how many were urban, how many were rich, how many were poor. And what happened was, this was near the end of the decade, so they were using the census from 9 years before, and the country had changed a lot, so their quotas were set wrong. Now, they actually would have been better off using a random sample. If they'd have gotten a random sample with enough people, it probably would have represented the population more than their quota did. But because their quotas were set wrong, they undersampled urban people. And urban people, lo and behold, voted for Truman. So that's an example of where you can go wrong with non-probability sampling, even if it's designed to try to be more representative. Participation in studies is voluntary. People give informed consent and they have a right not to be in the study. You can't force it. That can be a source of bias, because the people who say no and refuse to take your survey might very well be different than the people who say yes. And so you might be systematically missing a certain kind of person or a certain kind of opinion. To consider an obvious example, imagine we're doing a study on attitudes towards privacy. Now, who do you think's more likely to refuse to talk to a stranger? People who have a strong feeling about privacy or people who don't? We might get a very inaccurate view based on who decides to talk to us and who does not. The technical term for this is non-response bias. a broader term that means basically the same thing as non-participation bias. We usually say response when we're talking specifically about surveys, but the same problem applies to other things like experiments, and in that case you might call it non-participation bias. Either way, it's a problem that arises because there's differences between the people who agree to be in the study and the people who do not. We can gauge the likely degree of non-response bias using a statistic called the response rate. It's a percentage of people that we sampled who actually responded to our study. And you want this percentage to be as high as possible. So when you see a study with a small response rate, a small percentage who actually answered the question, you should be skeptical and consider that there's probably a high degree of non-response bias. So to summarize, this section considers 4 main threats to the validity of research that uses samples. These sources of error are coverage error, sampling bias, random sampling error, and non-response error, and sampling methods are meant to combat these. For example, having large and random samples combats having sampling bias and random sampling error. So this is one thing you should keep in mind, is to be skeptical of surveys and polls you see reported in the news, even if they have a very small margin of error, even if they appear to be very accurate, they might actually have a lot of bias. And this is one lesson we should probably draw from the most recent presidential election. Going into the election, most of the polls were showing that Hillary Clinton was in the lead of Donald Trump, and yet Donald Trump won the election. So there was something off about very many of our polls during the last election cycle. And modern pollsters nowadays, they use large samples and they use random selection. So the problem was probably something to do with response bias or bias in the sampling frame. We'll consider these issues in more detail when I return. For now, just feel free to contact me if you have questions. Otherwise, I'll see you next class.